Hello everyone. In this video, we're going to be going over how we created our 6-point light shader and set up a showcase particle system for our scene. If you're interested in how we created our textures, check out our Intro to Houdini Pyro course. We hope you enjoy this one and we'll see you in the next one. All right then, let's get started. So first, let's start with our explosion material. And as you can see here, we have this kind of separated into two parts, which let's see, I don't need this right here. So this part controls the shader basically separately in different channels. So it controls the smoke, the fire, and the alpha. Here we have our controls for the, or not controls, but the math and the shader for our 6-point light setup. So to just go over this pretty quickly, we have a light direction, which is a custom HLSL code that allows us to use the buffer in the scene to get the light data. So here you'll see return view dot directional light direction, end quote. So what this will do, it'll basically take the light direction in the scene and applies it to our shader to tell the particle that the light is coming from a certain direction. So next, we're going to do a transform vector and get it from world space into tangent space. Then we're going to take that and split it into three separate channels. So we have the R, G, and B. And here we are going to have a multiply, which one multiply is a positive and one is negative. And here we're basically adding our red channel into a B. So basically the if statement, what it does, it allows you to compare, well, not compare, but switches between textures, or in this case, channels, and fades them across each other. So basically the first input is A and the second input is B. The third input is basically if A is greater than B, and then you have the fourth one, if A is equals to B. And then you have the fourth or the fifth input, which is A is less than B. So I know it's a bit confusing. Trust me, it took me a long time to even understand half of this, but it allows you to basically switch between separate textures, or in this case, different channels. So when you say, hey, the light is headed into the left side of my texture, what this will do, it will take the light direction and then basically fades out the other side of your particle. So it will basically just light the one side. So in this case, let's take a look at this thing. And if we just start previewing the node, if you hold L and you start moving, you'll see that there is a arrow, which is the light arrow in the scene. You'll see there is slowly a little bit of flickering. So that's me basically switching between the channels. That's basically based off of the light direction. So let's say, for example, we add or multiply these two values. You have the absolute, which is abs, and what that does, it basically tells it it doesn't allow a parameter or a value to have a negative value. That came out wrong. It doesn't allow a value to have a negative value. So let's say you have a value of 10, and then there's a sine, so a sine wave, and that value goes from 10 to negative 10. This doesn't allow it to do that. It basically takes it to 0 and back to 10, or like 1 back to 10. So if we multiply this with the absolute and the light direction, and then we go back into here, you'll see that it slowly switches between the channels. So if I add my 6-point texture into here, you'll see that it will switch between channels. So let's do that just to do a test case. And then we'll set it back to default in a second. So let's say for the first one, we are going to use RGBA, which is, let's say, yep, so this is RGBA. And then where is the other one? Nope. Yep, here it is. That should be RGBE. Cool. Okay. So just to showcase this, if we start moving our texture, our light, you'll see that the texture or the channel is switching between left and right. Left, because the light direction is coming from the left, and then right, because the light direction is coming from the right. So let's multiply that with this if statement, or not multiply, add them together. Now you'll have both light, both right and left, and you have kind of the top. So let's see. We have, yep. So the top and right. So now we have basically the bottom, top, and left and right. But what we don't have is these, which are the back and the front. So if you add those together again, you'll see that now we have a 6-point light control. So basically, this is how you set up the shader for a 6-point light setup. Next, so you're wondering exactly what are we going to do with the rest? So now you have your alpha. So this is basically going to be the alpha for the texture. And then we take that and then we set up a multiply to basically control the alpha on a gradient if we want. Sorry, on a scalar if we want. So we can control it manually. Then we have a parameter in here. So I set this up just so I can control it in the particle system for erosion. And this here is our particle fade, which is the particle color. And here is the fade distance, which basically does the depth fade for when it intersects with objects. So let's say, for example, your explosion is next to a car or something. You don't want it to have that hard cutoff. So this is what we use for that. And this is our fire. So here we have a power, and this is a scalar parameter. So you can use it in a material instance. And you'll see here, I have another one. So here's the thing, you can choose one of the two. You don't need to do both of them. Part of the reason I put two is because I was testing out whether or not I can actually set up one where I can control manually and one where I can control over time in my particle. So choose one and stay with it. I personally recommend the dynamic parameter because you can control it in the particle. Next, we have a intensity scalar, which you basically multiply your power in here. Next, you'll have the color, which allows you to change the color. This is a vector 4 or a scalar parameter also. And here is another multiply, which allows you to take everything that you had after this point and then multiply that value to give you a harder or a harsher result if you want. And here is basically the 6-point light setup, which basically gets multiplied by a color, which allows you to have a base color, and then that base color will be set to be basically the color that you have for the particle. And then if you have light in the scene, let's say, for example, if the whole scene has a light direction, it will show you the different sides of the 6-point light setup, but you'll still have a color in there if you want. And of course, we set an intensity value to control how intense the color is. And all of this gets added together and then gets multiplied with another custom shader, which what this does, let's say, for example, you're getting the light data from the buffer in the scene. This takes that information and actually adds a color, which whatever the color in the scene is, like the overall scene, the smoke will take that color. So basically, it's ambient color in the scene, which is something that you really want when you're doing a 6-point light setup. So yeah, basically you do a mask RGB, multiply it, and set it in the base color and the emissive color. And that's basically our 6-point light shader with the way to control the individual channels. All right, now that we finished our explosion overview, let's move on to the fire. So for the fire, it is a little bit interesting because as you can see here, we don't really have any wind or anything in the scene that simulates wind. But what we've done here for the actual shader, we kind of faked that we have the ability to show wind. So to do that, we ended up setting up a way to control it using the UVs. So the result would look something like this. So what we've done here is we added a time node and multiply that to basically slow it down by 2 separate multiply. And then we added a sine node. So now you'll see that it is kind of blinking. So it's going from 0 to 1. So if we look at how a sine works, it would be something like this. So a sine wave goes something like this. And if you set up the actual numbers in here, so you have, it goes from 1 to -1, back to 1 into -1. So that's basically what the sine is doing. Like, you don't mind the actual parameter, it's just because you can change that, but this is what a sine is. So let's remove all of this. So now that we have that there, we added another sine with a different value. So the actual timing of it is longer. Then we multiplied it together and then set up a constant bias scale. What this will do, instead of our sine wave going from -1 to 1, it will go from 0 to 1. So basically it's fitting the range into 0 to 1. And then we're lerping this into here. So we have -0.07 and 0.12. And here on top, we have our coordinates. We're setting up a frac. So basically the coordinates need to be the same thing as the as your flipbook. So if you have 6x6, you would change this to 6x6, but for this instance, it's going to be 8x8. Next, we're going to change it to the green channel, or we're going to make a mask for the green channel, and then we are inverting that. So in the terms of the UVs, technically speaking, we have it top to bottom. When you inverse it, you have it bottom to top. Then using the power, we're going to shift the value a little bit. And then we multiply everything together and make it into a float 2. and then add another text coordinate. So now you'll see slowly there are a little bit of lines here. So this is basically the rows and columns that we've set up. And you attach that to the UVs, and this is the result that you'll get. All right, so here we're basically just setting up the flipbook animation. So if we preview that, these are our RGB. And then we're setting up a static switch, which we can basically control if we wanted to use this for a mesh or not. Because the technique for this one is interesting, because you can use this in a way where you can control it using a mesh or just the particles. So this shader does it for both of them, but you have to control it by switching between particle and mesh. Okay, so the rest here is basically controlling the fire. So this is for the fire, and this is for the alpha, and it's exactly the same thing, the same setup for the explosion. And the only thing that is different here is this. So basically, this is the same technique for this, but for meshes. So this technique here uses the UVs of your texture to drive the movement. But for this case, which is this right here, whoops. We're using a math to control the shader. So the top part of it is basically exactly the same thing that we did for the UVs. And the only differences here is in the vertex color. So here we're having a time node, multiplying it and adding it to a vertex color, sine wave, multiply that in the same instance as we did here. So as you can see, instead of going through the same way, we only added a sine wave, not a sine, a color, vertex color in between. So what this will do, it will allow us to control it the same way, but using the vertex color. Here, we're going to add it and then multiply by 0.5. And then here we have our constant vector, which is set to -60 in the y-axis. And then we multiply everything together. And again, we have a use mesh static switch or parameter switch. And basically what this will do, if you choose to, let's say, for example, have a mesh and you will attach this shader to, make sure your mesh has this setup. So the bottom part of your mesh would need to be a darker shade. Then by the time you get to the top, it needs to be red. So it would look something like this. Now this is pink, but you get the point. So it would be a gradient from 0, which is black, and 1, which is red. And that way, only the top of the mesh will start moving, and then the bottom of the mesh will be static. Okay. But mostly, if you don't want to use this for extra movement just to make it look better, and you're like, hey, I just want to know how to control the fire itself, you can do that here. It's basically a power node, a multiply, 2 different scalars, and basically this setup here, and you input everything into emissive color and opacity. And overall, you should get something like this. So technically speaking, this is set to a mesh, so we can turn that off. But if you want it to be set to a particle, you can have it set differently. So you would have this for a particle, and then you would add that together and so on. So the intensity of everything is depending on how you set it up in the material instance. All right, everyone. Now that we finished our overview for the materials, we're going to be looking at the particle system and why we decided to do the things that we did in our shaders to basically showcase our explosions. So for the first one, I'm basically going to use the explosion textures, and I'm going to make copies of them and then showcase them in my scene. So for the first one, I'm just going to go with our fireball. And let's make a Niagara system. And let's add a single looping particle. And let's call this explosion. And then we want to add our material in here. So here is our flipbook. And let's go ahead and set the sub UV to 8 by 8. Next, add a sub UV animation. So this is what's going to allow our particle to basically animate. And change the sprite renderer in here, and you'll see now our explosion plays. So let's change a couple of things. Change the lifecycle mode into self and ask it to do it infinitely. So now I will infinitely keep going and change the current loop duration. And you can set that, for example, to 5, 10, whatever you like. For now, I'm just going to set both to 5 because I'm going to showcase it in my level, and I just wanted to play so you can see the changes. So if we save this and add it into our level, oh, it is too small and we're not going to be able to see it. So I'm going to increase the size to, let's say, 250. Yeah, I think that should be good. So now you can see there are two things that I want you guys to notice here. So one, we have color that is different from the view here. And part of the reason that is because it is getting light from the actual scene. So the scene here has basically no light direction, or it does have light direction, but it's a normal color, like basically white. Here, you'll see the warmer tones in our smoke. So that's basically what we did here for our shader. So this is the reason, the light color HLSL node. And basically, you'll also notice that the light is coming from this way. So let's say I pick pen. And let's wait a second. Here we go. So now you'll see that the light direction is coming this way. And you can also tell by this arrow. Now, if I do want to change anything here, it will have to be the light direction if I want it to look something different. So now you'll see that the light direction is coming this way now. But of course, because the particle is camera facing, it's going to keep moving with my camera, but you'll get the gist of it. Okay, so that's for the first part of this. And now let's talk about this part here. So here we have a dynamic parameter. What this does, it allows me to control my particle over time. So let's say inside here, I have the intensity of my fire that I want to change. So I can come here and add a dynamic parameter. You'll see that this immediately changed. That means that the erosion and the fire intensity are active. So what we can do here is set up a curve, float from curve, and as you can see, if we play this, it does change based off of our curve. So basically, this is just a layer of control that we use to control our explosions over time. And this is why you'll see a lot of VFX artists, like, and I mean a lot of us, work with curves, numbers, parameters, whatever it is that we got to do to make sure that the effect look good. So in this case, I'm just going to reset the fire. Just set it to 1. I think that should be good. Yep. And then the other thing is our erosion. So here's the thing. It depends on what type of alpha you have in your smoke or in your explosion. I generally tend to erode and dissipate my explosions. So what I mean by that is erosion is basically taking the value 0 to 1. So let's say, for example, your alpha has a value of 0. Let's see. Has a value of 0 and 1. That means 0 is basically black and 1 is white. And in between this is basically a gradient that goes 0 to 1. So what we're going to do is basically use that gradient and tell it when it's at 0, it's completely dissipating. And when it's at 1, you'll see something. So that's what we do with subtract, where we use that here, because we're subtracting from our texture. So that being said, that's basically what we do here in this area. So for example, you'll see how it's eroding from the sides. And now you'll see there are slowly like this outline here. What I do with that is the next step, which is the particle color when you attach it to the alpha. So what this does, it basically allows the particle to fade over time. So it's a 2-layer fade, basically. So one layer is the erosion, and the other layer is our fade. Okay, but I would say use this at your own discretion because it is really powerful and depends on your level of experience. It is easy to mess it up. So this is one of the things that you need to be careful when you're messing with. Okay, so now that we have these here, so let's play this again. Because I want to see, okay, everything looks good. I think that should be it for the particle. So for this one anyway. So I just want to make sure. Yep. Okay. The other thing that I wanted to show you guys is inside here. All of these can be made into a dynamic parameter if you wish to. But for this instance, I'm not actually going to do that. Partly because I like to control things in my material instance, but that's me. I've seen a lot of VFX artists use the dynamic parameter, for example. And here you'll see a parameter index. So what you can do is copy this, set this to index 1, and then you can change the name in here and then attach it to every single one of these. And then inside the dynamic parameter, you'll see that index 1 is here, 2, and 3. Keep in mind you only have 4 indexes here. So yeah, use it sparingly. But yeah, the rest is basically our dynamic parameters and the scalar parameters here. So this is what we have to control our uh, shader. Okay, so next I'm just going to copy this and just add the second explosion. And we're going to be using a dynamic, no, not a dynamic, system location. And then we're going to move this in the X axis. So here, it depends on the location. You'll see it this one. Okay, so now let's increase it a little bit more. I think it was a bit much. Okay, perfect. Next, let's make another one. And let's add the third one in here. Let's find it. There we go. Okay, so now that everything is good to go, let's go back to the location and do negative for this one. So we would see something like this. All right. Yep, that's it for the explosion. So next we're going to add our smokes. So actually, I'm just going to make another copy of these. So here's the thing. It depends on what type of showcasing you're trying to do. For me, I've made so many flip books that I actually have to showcase them in a level just to see what I've done. So it depends on how you want to approach this. Do you want to showcase this as a level, like to showcase your assets and what you've been doing, or you could combine these and make them into a explosion kit bash. So it's up to you. Okay, for this one, let's add in our smoke. Or actually, let's do the fire first. So let's add the fire in there. And that's not going to work for this one, but it will. That's part of the reason we set up a switch parameter. So let's set this to something like this. And going to the material instance, we uncheck use mesh. And now you'll see that we have our fire in here. And we can basically showcase it. And for the color, of course, we can go to the initialize particle, direct set, and change this into fire. Okay. So let's do 800 instead. Okay, a bit closer. And again, you can change this to the rest of the fires that we've done. It's all up to you. Okay, now the fire is done. Let's make another copy and add our smoke in here. So we have two looping smokes. We have this one. And let's add that. And let's change the location to -1000. Here, I'm just basically setting up a showcase level to show you guys like, hey, if you want to do this, it'd be easier for you to use kitbashing. So basically you can go into this parameter, this particle system, take your emitters and use them in different effects. Basically everything is ready for you to use. Okay, And next, let's go inside here and change the alpha to 1. It was a little bit too much, so let's change that. And next will be the final explosion. Oh, not explosion, the final smoke, actually. Okay. Okay, what's this one? Yep. So we're going to take this and let's apply it here. And then let's move this even more. Okay. Now I'm wondering, why is it orange? Oh, right. Whoops. There we go. So yeah, that's basically the setup for everything that we've done so far and the reasoning behind why we set it up the way we did.